In the last video, I got through 2/3 of the inheritance challenge, as shown on this diagram. I created the worker and the employee classes with the fields and methods shown here. I also overrode the toString method, which you know by now was originally declared on the object class. I overrode toString for the worker and then overrode it again, but extended it further for the employee class. It's time to build a more specific type of employee, one that's salaried or one that's hourly. A salaried employee is paid based on some percentage of his or her annual salary. If this person is retired, then the salary may be 100% of this amount, but it is generally reduced somewhat. An hourly employee is paid by the hours worked and the hourly rate they agreed to work for. An hourly employee may also get double pay if they work over a certain number of hours. The challenge asked us to just pick one type of employee and build it out. And I'm going to create the salaried employee, so let's focus on just that class. We see that I have two new fields that are specific to a salaried employee. These are annual salary and a flag is retired, a Boolean. This means our retired person will still get paid but not his or her full salary. I'll have one method retire that will set the isRetired field to true. I'll create a new class in our inheritance project called salaried employee. And I'll add extends employee right away after salaried employee. And that won't compile as we see without a constructor declaration that calls employees constructor. But first, I'll add our fields for this class. Double, annual salary. Boolean is retired. I will generate the constructor with a single parameter, annual salary. Remember that isRetired is false by default and annual salary is initialized to 0. I can create a salaried employee with just one extra field than I did with the employee, the annual salary. At this point, I'm ready to hire a salaried employee. In fact, I'll just change my main method and make Joe, my second employee, a salaried employee. I'll change the references to salaried employee and then add his annual salary as the last argument. Running this will give me the same output because I haven't overridden toString, and actually I don't want to. I wouldn't want my employee's salary to inadvertently get out, so I'll keep it well encapsulated and I won't print that out on the toString method. I do, however, want to override the collect pay method on worker so that Joe can get paid. In the salaried employee class, I'll add that method. Let's say salaried employees get paid every other week, so I want to divide Joe's annual salary by 26 weeks to get his fortnightly pay. For now, I'll just pay in whole dollar amounts, at override. Public double collect pay, return casting as an int, annual salary divided by 26. I'm casting the returned amount to an int for simplicity's sake. You wouldn't do that in real life, of course. And I'll make a call to that method in the main method. Println some header text and the result of calling the Joe object's collect pay method. And running that, you can see that Joe's paycheck equals $1,346. Now, I'll implement a path to retirement with the method retire on salaried employee. I'll start by defining the method. I'll call the terminate method passing the 12th of December 2025, and then I'll set isRetired to true. I start by calling the method terminate. Do you remember which class defined the terminate method? It's on worker, the grandparent of this class, or the base class after object. As long as the parent class doesn't override its parent's methods, then these methods can be called from any descendants. Next, I set the isRetired field to true. Before I retire Joe, I'll edit my collect pay method. Let's say the maximum pension can only ever be 90% of their final salary. Double paycheck equals annual salary divided by 26. I'm using a ternary operator to cap the adjusted pay to be 90% if they are retired, otherwise the full amount. Return the adjusted amount, casting to an int, and going back to the calling code, the main method on main.java. Call the retire method on Joe's object, and print out the pay amount by calling the collect pay method. And now running that, I've found out that Joe's pension pay will be $1,211. For the salaried employee, I overrode collect pay, a method declared on worker, and I implemented it using code that was unique for a salaried employee. I also implemented a method that wasn't found on either worker or employee because it really only made sense for a salaried employee, which was retire. So did you implement salaried employee? Were you able to do it successfully, or maybe you implemented the hourly employee class? I'm actually going to walk through that next. Let's examine that class briefly. On this one, we have one additional field, hourly pay rate, which is what this worker will get paid for each hour worked. We'll also implement a method called getDoublePay. I'll create a new class in our inheritance project called hourly employee. And now this one too should extend employee as I did with salaried employee. I'll have a compiler error until I implement a constructor, but first I'll add my field. Private double hourly pay rate. I'll generate the constructor using this field. Then that gets rid of my compiler error. In this case, I'll be passing the hourly rate for my hourly employee. I'll add the two methods. I want to implement collect pay for this class, overriding the one on worker just as I did for the salaried worker, but with a different calculation. In this case, I'll just assume that my hourly worker gets paid weekly and that he or she works 40 hours a week. At override, public double collect pay, return 40 times hourly pay rate. And now I'll implement getDoublePay. I'll make this one simple too, for the sake of time, and just return double the amount of the normal pay. Public double getDoublePay. Return 2 times collect pay. This call to the method collect pay will call the collect pay method on this class and not the collect pay method on worker. Moving over to the main method, I'll create an hourly employee named Mary and I'll make her hourly rate $15. First, I'll create the employee and just print out the employee data. Hourly employee Mary equals new hourly employee, and I'll pass Mary then the 5th of May 1970 and the 3rd of March 2021, and lastly 15 as the arguments. I'll print the Mary instance. Next, I'll print out the results of calling the collect pay and getDoublePay methods and running that code. I got the information for Mary. You can see her employee ID is 3 and her weekly pay is $600. Her double time pay would be double that, or $1,200. That was a quick implementation of the hourly employee class. Did you pick that one? And did it look anything like my version? Or are you still a little confused about what we did? Let's see if we can figure out what we really did here. This slide is showing our Joe and Mary objects. Each method call made on these objects points to the code that will actually be executed. In other words, it shows where the method is and what class it's in. This isn't always so obvious when you're using inheritance. When Joe or Mary call getAge, the method's implementation is on worker and is not overridden by any other class, so the getAge method on worker is executed. When Joe or Mary call toString, this method has been overridden twice, first by worker and then by employee. But it wasn't overridden by either salaried employee or hourly employee, so the method from the employee class is the one that's used. Looking at the collect pay method, this method was overridden by both salaried employee and hourly employee. Joe will execute the method on salaried employee, and Mary will execute the one on hourly employee. Finally, salaried employee has a method retire that's not overridden, meaning it's only in that class. It's a method specific to a salaried employee. An hourly employee has its own method, getDoublePay, which wouldn't apply to a salaried employee, so we declared it in this class and not in any superclass. Okay, so that was the challenge. I hope you got a lot out of that. If you're still confused, don't worry. The next two videos are going to review some of the points we've covered, so let's move on.